An arithmetic sequence is a particular type of sequence. To build our understanding of arithmetic sequences, we start with an example. 5, 9, 13, 17, and so on. Can you see the pattern in this sequence? Here, we are adding 4 to get from one term to the next. 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4 is 17. So the fifth term in the sequence is 4 more than the fourth term. The 100th term in the sequence will be 4 more than the 99th term. In general, the nth term will be 4 more than the n-1st term. To calculate what the third term is, we start at the first term, which is 5, and we add 4 until we get to the third term, which means we add 4 2 times. So the third term is 5 plus 2 times 4, which is 13. The main questions we asked ourselves here were, where do we start, how do we move from one term to the next, and how many moves do we have to make? Try and find the 100th term by answering the same questions. The sequence starts at 5. To move from one term to the next, we add 4. To get to the 100th term, we have to add 4 99 times. So the 100th term is 5 plus 99 times 4, or 401. What about more generally? Can you find the nth term by answering the same questions? The sequence starts at 5, and to move from one term to the next, we add 4. To get to the nth term, this means that we must add n-1 fours. So the nth term is 5 plus n-1 times 4. Now that we've seen an example, we can write down the definition for what an arithmetic sequence is in general. An arithmetic sequence is a sequence that satisfies the recursive relationship. To move from one term to the next, we add a fixed number d. To express this algebraically, we say that the nth term, a(n), is equal to the n-1st term, a(n-1), plus d. The most general case is having a sequence a1, a2, a3, and to move from one term to the next, we just add d. Think about what the nth term should be by asking yourself the questions we found helpful for our example. The questions we want to answer are, where do we start? How do we move from one term to the next? And how many times do we have to move? We start at a1, the first term in our sequence. We add d to move from one term to the next. And we have to add d n-1 times to get from the first term to the nth term. This means that the nth term is equal to a1 plus n-1 times d. We worked with an example. We wrote down the definition, and we found an explicit formula for the nth term in an arithmetic sequence. You should now be ready to try some problems for yourself.